like to show you how to use Mathematica in the context of a campus grid. I hope that by the end of it you will realize that installing Mathematica and getting it running in a campus grid is super trivial. And it should be really easy for you to do this for your researchers. So what we do at UChicago to get Mathematica running in our campus grid is we use the CERN Virtual Machine Filesystem, also known as CVMFS. And if you don't know what it is, it's just a HTTP-based read-only file system that does a lot of caching. And what I did was I just installed CVMFS, or I'm sorry, installed Mathematica into CVMFS. I just grabbed the regular Mathematica installer and I ran it, and I pointed it at this location, which is the location of our CVMFS server. So by doing that, then we install it in a central location, and it gets replicated out to all of these worker nodes that are connected in the various clusters in our UC3 framework. And UC3 is the name of our campus grid. If you didn't know, that's the University of Chicago Computing Cooperative. So anyway, the first thing I'd like to try to do here is try to run Mathematica on my submit host. So I make a Mathematica directory. Oh, and I guess I should also explain that this is proprietary software, and we do license this from Wolfram, and there's a campus licensing server that we use. We did run our own license server for a little bit, but we found it worked better for us to use the campus licensing server. So I'm going to make a working directory for my Mathematica jobs, and I'm going to go ahead and make some directories for my output files and logs in Condor. And what I'm going to try to do then is run Mathematica that's been installed into our CVMFS repo. So I just need to set up my path appropriately for that. And I will try running it. Looks like it works. I think we can say license, perhaps license server. That says that we're using the campus license server. We can actually verify that we can do something like run 100 factorial. We get a nice output. So I'm fairly convinced that Mathematica works. And I broke it. Worked. It doesn't like backspaces very well. It puts them in as control H's in this interactive mode on the command line. So for this particular example, I've written some code that calculates out the Mandelbrot set. I don't really like sleep job examples, so I thought I would try a real-ish example. The code is here. If you have the Mathematica, you can just copy and paste this and create a appropriate file. So I'm going to paste this in here. It's, I'll spare you the details, but the thing to know here is that there are two variables that this thing takes. It takes the number of jobs that we'll be running, and it takes a PID to determine which chunk of the Mandelbrot that it'll calculate, since this is a pleasingly parallel type of problem. So we can try running it. Let's see, we have Mandelbrot.m. And we have Mathematica. So there's a bunch of input there and a bunch of output. And it created a CSV file for us. Not very interesting looking right now, but I will plot it later, and hopefully we'll see a really nice picture. And this is all running out of CVMFS, so this is not installed locally on this machine. This is a cached version of the Mathematica software. So it's pretty straightforward to make a Condor job for this. We create a wrapper called math.sh that just takes our Mathematica input files and can also pass some extra stuff like variables into the code. And we also, I've also made this a little bit generic because I want to use this with another Mathematica script a bit later. So this is pretty straightforward. It just sets up the path for us because when Condor runs our jobs, it's going to need to know that Mathematica is in this CVMFS location. And make sure we chmod it to +x. And then I've created a Condor submit file for this. Again, this is very standard stuff. I've just created an initial dir to put all my output files in there, and I also have this requirements line. So so for any cluster that's mounting our CVMFS repository, we have them advertise this Condor class add in their configuration on their worker nodes to just say has CVMFS equals true. So then this job will only match against those worker nodes. And we also have some accounting groups set. So I will go and I will change this to be my name. And I've also defined this variable here, jobs equals 10. What happens here is this is the number of jobs I want to run, so I make sure that my Mathematica script knows that, the total number of jobs, because that's how I've set this up to cut up the Mandelbrot set. And then I just queue that number of jobs. So that should be good. And then I believe we can try to Condor submit it. And this might take just a little bit to get running. It depends on how much load there is in our Condor right now. It looks like we have some room. So these should hopefully start running here in a second. So while that's doing its thing, we can go ahead and talk about this. So when these jobs are done running, they'll spit out like 10 CSVs for us, or N CSVs, where N is the number of jobs that we've submitted. So then we need to stitch these together and make a single CSV file for us to plot later. So this is pretty straightforward stuff. I just created another Mathematica submit script that will do just that, and it looks like these jobs have completed. We can see them all here. And I will create this file. That just puts those together. And I'm also making the submit file for this. And again, I'm going to change username to be my username. This is all very easy, and hopefully doing something like this would be super easy for your users. So we've submitted that job. We can watch this guy run and hopefully start up soon. Optionally, you can also do this with a DAG. This is really straightforward to do with a DAG, right? So it's very linear. It just launches in number of processes and then stitches them back together. And we can use this fun DAG stuff like retries and whatnot. And that's all in here. I chose not to do that for the purposes of the tutorial. So once this is done running, we should get a nice Mandelbrot.csv, and we see that it just changed a run state. So it shouldn't take too long to run. Looks like it's finished. And we see Mandelbrot.csv. Remember, Mandelbrot 01 is the one that we created earlier when we were testing the code. So I'm going to open a new shell and make it nice and big so it can be read. And unfortunately, I couldn't get Mathematica to export a picture running it in batch mode. For some reason, you have to have the the GUI running in order to export PNGs, which is kind of weird, but I can live with that. So I'm just going to SCP this CSV back to my laptop here. And then I'm going to fire up a local copy of Mathematica to see if we actually did this correctly. So I just want to get this, get rid of that extra slash, Mandelbrot.csv, say Mandelbrot equals that. Should import it, said that the very large output was generated, that's to be expected. And then I have some array plot options here. And all we're doing is just plotting this CSV. And there we have it. We've calculated a rather small but nice little demonstration of the Mandelbrot set. And then there was one more thing I wanted to talk about, which was in these campus grid contexts, you may not always be able to go to another sysadmin or another group and say we'd like to mount this unknown file system on your worker nodes. So you can use Parrot, which I provide a little link to the tool webpage here at Notre Dame. So you can use Parrot to talk CVMFS natively in user space and and intercept those system calls. So I wanted to do this with the Mandelbrot set, but I found that the performance wasn't so good, and that's something that we should spend some time researching and figure out why that is. But I was able to get a trivial piece of code running that just prints out the version of Mathematica and does a factorial for us. So actually what I'm going to do is SSH to another machine that does not have CVMFS mounted. Just want to show you that there are no tricks up my sleeve. And I'm going to run this script I made that just downloads the appropriate release of Parrot and runs it. And do that. I'm just going to make a directory called Parrot. Nothing in here. First, I'll make that Mathematica file. And again, we try to run math, it's not there. So then I'll grab this script I wrote. And this doesn't really do anything special. The only thing it does is give Parrot our public key for our CVMFS repo, and it also sets up our HTTP proxy and grabs the appropriate version of CC tools for our release of Scientific Linux. And then the meat of it here is running Parrot, giving it the options for CVMFS, and then executing Mathematica. Make sure we use chmod plus x. Let's see if it works. There's this little error here, and I don't know what that is. So if anybody's an expert with Parrot, I'd love to know. But you can see that that it did read Mathematica via Parrot, via the CVMFS server, printed out the version for us and factorial of 100, and told us what host it was running on. So at least it's as a proof of concept, it's solid. But again, we need to do some more work to figure out how to get stuff like Mathematica to be more performant with Parrot, so we can truly run it anywhere on the campus. So that's all I had. Thank you. If anybody has any questions, I would.
Thank you, Lincoln. There is a question from Miha in the chat. Yeah, he's asking if students not in science could use this. I mean, it's a basic Condor job submission at the end.
Mm-hmm. Yeah, this is you know, I haven't, you know, I don't have any rabbits pulled out of my hat here with the Condor submission. The Condor submission is very vanilla, I think. Nothing special has really been done. You know, this is certainly an opportunity where a student could do something like use Bosco, right? And they could install Condor on their Mac and do it all from their Mac and log into our submission host, and pretty much all of that would be obscured away from them. As long as they're willing to follow this tutorial to get an idea of how to run a Mathematica code. Really, this is the only thing special in the Condor submission. They would basically, the only way they would change their Mathematica workflow is they would be writing Mathematica batch files instead of running in the interactive mode. I hope that addresses the question. Oh, that's
so
great,
I will
Ben.
reply to Miha here. Mathematica is a closed code, so it's not
well, I will try
possible at the moment
to
modify. I mean, it's not possible to modify unless we start a collaboration with the code. So this is definitely beyond the goal of this tutorial, to try to have something going through the Mathematica interface.
Mm-hmm. So there is so there is one thing that could be done, and that is using MathLink. I believe that's what it's called in Mathematica land, where you can create, you know, call out to some external C program or Python program, and then have the Condor stuff done there. I remember at Condor Week there was a presentation regarding using Condor from within MATLAB, and it was completely transparent to the user. And I think something similar could be done there. Wolfram Research actually does. They do have support for, say, Grid Engine and PBS and Mathematica already. So if depending on how open those bits of Mathematica are, it might be possible to create some sort of Condor-friendly submission. And again, maybe this is something that Bosco could be used for. I haven't thought about it, and this is all off the top of my head. But maybe if you can submit to PBS.
There is a question. There is someone typing at the moment.
Any other questions? Cool. Thank you. Oh, is this documented?
Yeah, if you go, everyone, if you go to the chat window in Adobe Connect, there are both links to today's agenda that include the link to Lincoln's tutorial, and also direct link to this tutorial that he showed on his window.
So all of this documentation
you can,
that I just
if you are on campus
right
here, you can reproduce it. If not, you'll have to have a Condor cluster and Mathematica installed on your campus, or at least a license for it. So thank you, Lincoln, for the presentation, and thank you everyone for attending. So just a reminder that in the minutes page, you'll find also a link to the series of seminar from Campus Grid. So the iForum and the webinars that are once a month, they are all in the Campus Grid page, and here there is a link in the chat window. You'll find the previous edition, and soon you'll find also a video from with a recording of today's session.